Okay, let's start out with section 8.3. Now, section 8.3, we're actually using the T-chart in the book, so we're not going to go on down to the Z-score. The reason why, our sample sizes are pretty small, okay? Now, this problem is really weird because they give you two numbers, and you need to figure out which one is your N. So our students, whenever we were doing the review, some of them were a little confused about, it says the average cost of gas for 6 gas stations. Guess what? You don't need that 6. All right? And then they tell you it's $2.90 per gallon. A gas station claimed that the average cost of their gas is $2.80 per gallon for the past 15 days. This is N15, so that's kind of weird, but it's because you're looking at this over 15 days, and the 6 gas stations that have the average of $2.90 don't matter when it comes to N, but it's worded a little tricky, so I think a lot of students make that mistake right off the bat. So the first thing we need to do is that this gas station is saying that they have cheaper gas, okay? Cheaper gas means we are looking at a left tail test, all right, because we're saying less than. So our hypothesis is H naught mu is equal to 290, and H1 mu is less than 290. Now it's asking which one is the claim. This one, because we're claiming that, okay? Find the critical values. Well, remember, if you do your T-chart, you have to do N minus 1, which would mean that I'm looking at 14. So I find the alpha that's 0.05, one tail test, 14. Please look in your book and make sure that you are able to do this. And I can't read these numbers at all. So this is something like here, and this is negative 1.761. That is my critical value, okay? And I'm going to compare my answer to. Now, so anything that falls into this category is going to be in that. So let's compute the test values. It's the same formula. Instead of Z, it's T. But it's the exact same formula that we were just using, okay? Alright. So, well, actually, it's not sigma. It should be a little S. But really, it's not going to make a huge difference. Let's be realistic here. Okay? Alright, now. Okay, so from here, I'm going to go ahead and plug everything in. 280 minus 290. Alright, all over 0.25 divided by the square root of 15, I end up with negative 1.55. Is that going to fall into the danger zone? No. So because it does not, we do not reject. I'm just going to circle that. And if I had to summarize, there is not enough evidence to show that the $2.80 gas is cheaper than the other gas stations, okay? That's all you got to say. Look at the next one. Alright, so similar type of problem. Let's assume the average score in a math final is 72, so that's going to be part of our hypothesis. The professor's claiming that his final was 79. They want to know is his higher. So if it's higher, I know it's a right tail. So we're saying greater than. H naught mu is equal to 72. H1 mu is greater than 72. What's the claim? That one. He's claiming that. Now again, we're using the t-test. If we look here, he has 6 finals. So n is equal to 6. So n minus 1 is going to give you 5 when we look that up. I know it's right tail, so I picked the bigger value, which is going to be like, 2.015. So if it falls into the danger zone over here, then I know that there's an issue. Let's go ahead and compute this, okay? Because, again, we're looking at one tail, this. Looking at that. Hopefully you can figure that out with the chart. I can't show you physically in this video. Go ahead and compute my test value. I get 79 minus 72 all over 20 square root of 6 is equal to 0.857. That does not fall into the danger zone, so we do not reject. If I had to summarize, there's not enough evidence to show that his final exams are higher than the department average. All right. Okay. Now, so the average body temperature reading is 98 degrees. A sample of 39 body temperature readings are taken and found that the average is 97.6. Sample standard deviation, enough evidence to show that it differs. If it differs, we know it's a two-tailed test. Okay? So state the hypotheses. H naught is mu is equal to 98, and H alternative mu does not equal 98, okay? Now from here, we are looking at a sample of 39. Now this is kind of a weird problem because as far as I know, if you have 39, that's bigger than 30, you don't need to use a t-test, you can use a z-test. But according to what my information from the answer key to this, they use the t-table, which does have 39 and it has 38 on there. So you would do n minus 1, which would be 38, which it really does have it on there. But I would say anything over 30, go right to the z. I think either way, it's going to get the same conclusion, maybe not the same test value that you try, but you never know. So you look this up, you're looking at an alpha of 0.01, looking at 38, the two-tailed test, you figure it out that you end up with 2.712 and negative 2.712. If it falls in either one of those categories, we reject. So computer test value 97.6 minus 98 all over 0.90 divided by the square root of 39 gives you negative 2.776. Now, on the negative side, negative 2.712 is less than that, so this does fall into the danger zone. So we are going to reject, and if I had to summarize, we would show that there is not enough evidence to show that the average temperature is 98 degrees, okay, in this case, because we reject it. Moving on to the next section, I'm going to do a few from here before I stop this video. It says here, now 8.4, notice they start with percents. This is dealing with this p-test, okay? And you can do the p-value, all right, as well. I'm going to show you the p-value in one of these, and this one in particular, because I noticed a lot of students were saying that they didn't really have to do that, so I'm not sure what kind of teacher. So I'm not, I don't want to confuse you if you don't really have to do that on a regular basis. So let's look at this. All right. So talking about this, we're using the p-test. They say that the survey claims that 90% of doctors recommend aspirin. Random sample of 100 doctors. Hey, guess what? 100 doctors, we're not using the t-table no more. Of these 100 doctors, 82 indicate that they recommend aspirin. Is this accurate? They don't tell us anything, so that makes me assume, like greater than less than, that it's a two-tailed. So this is going to be a two-tailed test. We're going to figure out what those are in a minute. Let's talk about our H0. U is equal to 0.90 because it's a percent. H alternative, U does not equal 0.90. Now here's the deal. We got to find the Q value because we're dealing with this P stuff. Q is 1 minus P. Q would be 1 minus 0.90, which is going to be 0.10. We also need to figure out what's P hat. Well, P hat comes from whatever you're talking about with your sample. Divide it, which gives me 0.82. Now I should have everything at this point to go ahead and do my formula. The formula for this is going to be P hat minus P all over the square root of PQ multiplied together divided by N. We need to find our critical value. Now, we forgot. So critical values, go down to the Z. Looking at a two-tailed, alpha's 0.05. Figure out your Z's are going to be 1.96 and negative 1.96. Please make sure you do that. Now, I'm going to go ahead and plug all my stuff into there, okay? So in this case, I get 0.82 minus 0.90 all over the big square root of 0.90 times 0.10 divided by 100. Punch that into a calculator, you get negative 2.67, which is way into the danger zone. So we are going to reject. And again, if I had to summarize the results, you would say that there is enough evidence to show that this is different than the survey. Let's talk about the p-value. Where does p-value come into play? Well, what you want to do is you actually want to look up this number. So what happens is that you get your thing and you see, okay, here's negative 2.67. You find out that this shaded area, if you look it up in the Z-chart, this number, you figure out the area, 0.0038. But this is actually a two-tailed test. So I double that, and I get 0.0076. I take this number and I compare it to my alpha from the beginning of the problem. My alpha is 0.05. So So I say 0076.05. Notice that this is way less than that, so we reject the p-value. Okay? So I don't think you guys have to do much of that, because that's what it was kind of sounding like at least. But I'm just putting that out there in case you need to know how to do that, all right? Now stop this here and pick up with the next couple examples.